Okay, 7th graders. Lesson 8.3 has 2 things in it. We're going to spend 1 day on each thing, okay? So today we're going to be talking about the first part of lesson 8.3, which is the slope of a line. Okay? The slope of the line. Yeah, we talked about it a little bit last lesson, where whether it goes up and to the right, which is a positive slope, or whether it goes down to the right, a negative slope, or if it is flat, it's a horizontal line, which is a 0 slope. How else could a line go? A straight line.
Vertical.
A vertical line, right. A vertical line. And that's called an undefined slope. Because it's not a function, is it? It's not a function. Now, so let's write down some notes about slope. Okay? The slope of the line is the change in the y-coordinate over the change in the x-coordinate. Okay? Okay? So, that means that the slope of a line is written as a fraction. It's written as a fraction. The top number of the fraction tells you how far the line goes up and down. So as a fraction, it is how far up or down, and then over how far it goes left or right. In your book, it talks about it this way. It's the vertical change. Yeah. Over the horizontal change. So, let's look at some slope in your book. What if, on a graph, this is the graph on page 415, what if the graph was at this point, -6, 2, and the next point was at -2, 4. From -6,2 to -2,4. How much did this line go up from 2 to 4? If you counted from the y-coordinate 2 to the y-coordinate 4, that's a change of from 2 to 4 is a change of
2.
2, yeah, good, I even showed you. You can count up 1, 2, right?
Yes.
Do you have to do like little cursors?
What?
Do you have to do little cursors on it?
No, you can just count.
Okay.
Yep. Okay, now, how much does it change from -6 to -2? Well, from -6 it goes -5, -4, -3, -2. Right? If we were counting that. So what is the vertical change? The vertical change was from 2 to 4, right?
Yeah.
2, that's a vertical change of 2. And what was the horizontal change when we counted? 1, 2, 3, 4. Right? What do you think this line is? Is that a positive slope or a negative slope?
Positive.
It is a positive slope because it goes up and to the right. Now, what is the slope in terms of numbers? If the slope, since the slope is also written as a fraction, as the vertical change over the horizontal change, what is the fraction? 1/2. What does it mean? It means for every 1 up, it goes 2 to the right. Yep. 2 to the right. Okay? Remember that slope is always described as how it changes as it moves to the right. Okay? So you can count when you're figuring out the slope. You can count up or down and then how far it goes to the right. Okay? Now, there's another way to find the slope. And that is if you have these 2 points, if you know what the coordinates are, or if you look on the graph and figure out the coordinates of the point, then you can subtract to find the change in the y. So, let's write these points like this. -6, 2. That's point A. And B is -2, 4. Right? How can we subtract these to find the slope? Write this, draw this out. Okay? This is the second y, so we'll call this y2. That means that the 2 is y1. So write that down. This is the second coordinate of x, so we'll call that x2. And this is the first coordinate of x. We'll call that x1. Okay? Now, the formula for finding slope is to do this. y2 minus y1 over x2 minus x1. In other words, the second coordinate of y minus the first one over the second coordinate of x minus the first coordinate of x. Okay? How would we write that out in terms of numbers? Well, it would look like this. 4 minus 2 over -2 minus -6. Okay? 4 minus 2, -2 minus -6. Okay? Yes?
Wouldn't it be -2 plus 6? Because minus equals
Right.
plus.
Then, when you change this to minus equals plus, so it's -2 plus 6, and you get 2 over 4, right? the same number we got by counting it. And then reduce it to 1 over 2.
So you're saying we just had 1 over 2 the entire time? And odds and all that?
No, John, that's like saying, can't we just run the second without actually hitting the double? We actually hit the double.
He hit it in his head though.
We're being horrified.
He hit it.
Listen, you have to use a formula to get there. You have to learn how to use this formula, which is the change in the y coordinate over the change in the x coordinate. Okay? Now, so let's talk about what we've learned about slope so far. The slope of a line is the change in the y coordinate over the change in the x coordinate. So it is how far it moves up or down over how far it moves right or left. Or the vertical change over the horizontal change is another way to figure it out or describe it. Okay? If you're given a graph, one way to find the slope is just to count. Count from one point to another point. So from this one goes up to right 4. Up to right 4. See that pattern? Okay. That means the slope is 1/2, we would say. The slope of this line is 1/2. Not negative 1/2, but positive 1/2. You just say 1/2. Okay? Now, if you're just given the coordinates, you don't have to graph these in order to count and then find the slope. If you're just given the coordinates, you can find the slope by subtracting the y coordinates. And when you subtract the y coordinates, you have to keep the same order. That's why the second coordinate of y, you do y2 minus y1, and then on the bottom, x2 minus x1. Look at this drawn out this way. 4 minus 2, -2 minus -6. We're starting with the second one and subtracting the first one. And you have to keep that same order when you're calculating the slope. Okay? So make sure that you have this formula written into your notes also. y2 minus y1 over x2 minus x1. You might want to put it right here. y2 minus y1 over x2 minus x1. Okay?
How do you know which one's first and which one's second?
Well, it doesn't really matter. As long as you use the same order. So the second one that's written is just the second coordinate. That's one way. If you're just given 2 random points on a graph, you can pick which one is second or first. And as long as you subtract them in the same order, you will get the same slope. Okay?